We first looked at right angle trigonometry, and the question now is, well, what happens if it's not a right triangle? This is called oblique triangle trigonometry. Oblique meaning not right or not 180 degrees, something in between that. And so there are actually two laws, and the laws are produced using a proof with right angles, which I'm not going to do the proof, but there is one if you'd like to see it online. There are several people that have made one. And the law of cosines is used for non-right, meaning oblique triangles, that have a given side angle side, meaning that they give you a side, they give you an angle, and they give you a side, but the angle has to be in between. Or if someone is given side, 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 you can use the law of cosines to actually solve for the missing angles and sides. Keep in mind, this is not, though we're using the same language as geometry here, this is not a similar triangle proof or congruent triangle proof that you might remember from geometry. This is just the given information you have. So it's used to find angles and sides in oblique triangles. And the formula, as you can see, it looks a lot like the Pythagorean theorem. If you watch a proof on it, you'll see why. It's quite interesting how this is made. But we're just going to worry about how to apply it. So the way the formula works is you take what you need, which is called a, and you square it, and that's equal to the other two sides minus 2bc, meaning twice these two things, twice this product of these two sides, and then times cosine of the angle. Now, you can also rewrite this. If you were to subtract b and subtract c and divide by negative 2bc, you get the formula for the angle. It's important to understand how this works. Again, if I subtract b squared over here, and I subtract c squared over here, I would get this numerator, a squared minus b squared minus c squared, and then these are gone, so the next thing I would do is divide by this coefficient, which is how you make this. So I guess, students always say, do I have to memorize this? The answer is you have to know it, but you don't really have to know this one if you know this one. And I'm going to explain to you how to actually understand this. So it's not really a memorization. It's really an understanding of what the formula is doing. And I'll show you that in just a minute. I will also mention to you that this formula, sometimes people will pull a negative out, and you might see it in another textbook as b squared plus c squared minus a squared over 2bc, because they pull the negative out. I prefer this because it looks exactly like this formula when solved for cosine of a. And some students will say, well, why do we need them? Well, this one finds sides, notice the lowercase letter, and this one would find an angle, notice the uppercase letter. So how do we go about trying to deal with this formula without having to memorize a bunch of seemingly incoherent letters and squares? This is the way that I remember it, and it helps me write it out very quickly. So let's say you're looking for side B. So you would write down, I need side B. All right, and then what the formula says is you take the other two sides and you square them and add them together. Pretty easy, just whatever you have here, write down the missing things. Then you subtract twice those sides product, so twice AC, and since it's the law of cosines, then you multiply that product times cosine of the angle that you're given. And this is important, so whatever this angle is, this angle matches. And that's going to be very important to figure out why, for instance, side angle side and side 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 work. So what would I do over here? Well, you could do the same thing. If I want to find the angle, I would do cosine of B. And then you could either just write this one down and subtract, or you could say, well, this one's always the angle, the corresponding side of the angle, minus the other two pieces, the other two sides, and then always divided by twice these two product. It's not always BC, it's always whatever sides you're subtracting off, you divide by twice their product, AC. So we'll do it one more time, we'll do it with C, right? So C squared would be the other two sides, A squared plus B squared, so the other two sides squared and summed, then minus twice their product, AB, but then cosine of the side, right, the corresponding angle to the side you have here. So these two things, it always ends and begins with the same letter, one being upper, one being lowercase. So lowercase for the side, uppercase for the angle. To do it for this, again, you would do cosine of angle C, and that's going to equal side C minus the other two sides, and then divided by -2, negative twice their product, so A and B. Now, as you're looking at formulas, sometimes you say, oh my gosh, look at all those letters. It'll really fall into place when we look at examples, because these are the two things you'll actually have. And that's what I meant by you need this, you have to have this. So in this formula, if you want to find angle C, you have to have all the sides, right? And you can either be given them or calculate one of them potentially. And over here, this is all that you have in the problem. So every one of these things will have a number go into it. And that'll help everything fall into place. So just remember, whatever you need, it's the sum of the product, it's the sum of the square of the other two minus twice their product times cosine of that angle that corresponds to the side. And for the angle, it's what you have, it's what you need, what you're looking for, corresponding, right? C corresponds to C, B corresponds to B, A corresponds to A, and then subtract off the other ones. But you would need all this information to calculate it. We'll look at that in an example next. This first example using the law of cosines is going to focus on side, angle, side. Now remember, side, angle, side is not the same that you learn in geometry where you use it for congruence or similarity proofs. It's just the given information. You're given a side, an angle, and a side where the angle is in between the two sides. That's what that means. So when we look at the information, we're given that much, and we need to label it a little bit more. They gave us the labeling of ABC, just like we would in geometry class, but we need to remember that a side is called little c, and so we just go across from here and call this little c. We go across from B and call this little b, and we go across from A and call this little a. And that's probably the biggest change from geometry to trigonometry, because in geometry you'd have to call this side BC or something, but in trigonometry you just call it lower versus uppercase, and you can see I've set it up here. So when you see this kind of arrangement, we're solving for all sides and all angles in the triangle. So how do we use the law of cosines for this, and why are we using the law of cosines? We're using the law of cosines because it's not a right angle, and we're using the law of cosines because I have side, angle, side with the angle contained. So when I look at it, the first thing that I want to find is the side, because I need to find all sides to find an angle. So I actually need to find this first. So I would do c squared is equal to a squared plus b squared minus 2ab times cosine of the angle that is directly across from the side you're trying to find. And if I want to find the angle, it doesn't really matter which one you start with. They gave us c, we might as well find a. That would be a squared minus b squared minus c squared divided by -2 bc. And so those two equations, when you look at them, again, c squared, if I want to find the side, I need a squared plus b squared minus twice their product, and then cosine of the angle directly across from the side that I'm looking for. Keep in mind, when you use this formula, this and this should match always. All right, to do the angle, I'm going to do a squared minus b squared minus c squared. Of course, we have to find c to be able to do this, and then we divide by -2 bc. So in this one, these two, this one and then the leading one always match. All right, so next thing you're going to do is you're going to put in all the information, and as you can see, just to save time in this video, I've kind of pre-selected that information. A is 21, B is 15, and then cosine of 105. And then over here, I went ahead and put in what A and B were, and I don't know C. So I just wrote C. And this is actually extremely useful. You'll see in the calculator, you don't actually have to input C with, numbers. You can use the calculator to help you. I mean, you have to know what it is, but it will help you do that. And I'll show you that to you in just a second. So before we type anything in the calculator, we have to realize that these are not solved. So for instance, if I type this in, I'm going to get a number that is squared. So I actually need to type in this, I need to take the square root of this whole thing. And the reason we don't do that in the formula is it sure would be hard to go from a square root to this thing. So go ahead and put the square root in so that what we're going to get is C. And over here, you might notice, oh, well, I don't have angle A. I need to inverse cosine or arc cosine this to cancel this. And that's what you actually type into the calculator. So it's really important, if you haven't watched the video on right angle trig, it's very important to watch that video and understand why this has to be arc cosine because I'm finding an angle. And this one's really, just algebra. I got to solve for C. But the video is explaining why, sides are lowercase and why angles are uppercase and why I have to use arc functions in order to find angles. Very important video to watch before you've seen this one. So what I'm going to do now is I'm going to show you again. So that one comes out looking like that. A is equal to the arc cosine of this information, including C. And then I'm going to show you what happens in the calculator. You literally should type this whole thing into the calculator and then take the square root. Or if you're really good with calculator, just square root the whole thing and just realize the reason I did it like this is I want you to realize that this number makes no sense with respect to the other pieces of 21 and 15. The biggest mistake students make, believe it or not, is they think the answer is 829. They don't realize they need to take the square root. So once you take the square root, you get that the side you're missing is 28.793. And you can immediately store that. And so the way I did this on the calculator, there's a button for store. On the TI, it actually says STO, and it's on the left side of the calculator. And on the Casio, it's a little arrow. And the reason that's important is once I store that, I can then directly use it over here. Okay, so I can directly use that in my calculations in my calculator here. So you can see I just kind of kept going. So I stored that as C, and then I typed in that information, and then I inverse cosigned it. Now, when I say answer, if you inverse cosine on the TI, it will directly put this in there. So there's no reason to do it. But you could have typed it here, which would have been maybe just a little challenging. And please also notice that I had put the TI into fraction mode, which is alpha F1 to do this. Now, regardless, calculators in general are a little more frustrating than using a program like Desmos. So notice how nice and fluid it looks on Desmos. So on Desmos, I was easily able to type the entire thing in with the square root. Notice I got the exact same answer. I was then able to just say C equals that, and you can literally just copy and paste that in there. You don't have to find a special button. And then I was able to then type in inverse cosine of all of this information. I did have to type that in, of course, and it just goes into fraction mode easier. And I can then use C as long as I had defined that as C. I can just type C in, and I can use it here, and it will give me, as you can see, the exact same answer. So that's very convenient, and it's very fluid. And remember, on the SOL in the state of Virginia, you can use Desmos, and I would recommend it highly. It just really helps you see what you're doing. The only thing that students do in this chapter is they make little mistakes. They get things out of order, and you can clearly see it's 2115, 2115, 105. You can see how clearly it looks like what we wrote down. Again, the other thing people make the mistake of is they forget to take the square root, and they forget to use the arc cosine here. They say cosine on accident. They also leave it in radian mode. Look how everything's nutty in radian mode. You got to put it in degree mode. And also, if you don't want to type in cosine inverse, you can always type in arc cosine. Just make sure you put 2 C's in it. And the cool thing about Desmos is, watch, if you mess up, it'll put a little thing here and it'll say, oh, I don't know what you're talking about. You need to include some extra letters. Oh, I made a typo. Boom. And it gives me the answer. All right, so now we're going to take all this information and we're going to go organize it. So when organizing this information, you come back up to the top. You always write down what you're given. You could have done this first, but I wanted to focus on the equations. So I was given C is 105 degrees. I was given that A was 21 centimeters and B was 15 centimeters. Make sure you include your units. And then this one I got from the blue work here for the Law of Cosines for sides. I got it right there, 28.793. And then the 44.78 degrees I got from working through the Law of Cosines for angles, not forgetting my inverse cosine, and I got it right there. Please don't forget your degree symbol. So the question is, what about B? Well, you could go through the whole thing again, do cosine of B equals blah, 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 blah. Or you could simply use the angle sum theorem. 180 degrees minus the given 105 minus the found 44.788 is this value. So you could easily, if you want, I have no problem. Once you have shown me that you know how to use a law of cosines, I don't need you to show it to me twice. So please feel free to use geometry. I know that when we did right angle, there were some times where maybe we said, make sure you're using trig, but that's because, I wanted to make sure you could do sine and cosine, not just sine. Or I wanted to make sure you could do tangent of 2 ratios, not just 1. But, you're showing me here that you know how to use the law of cosines for sides. You're showing me here that you know how to do it with angles. Okay, to look at that on Desmos, Again, Desmos is just, I mean, everything's on the screen. So all you have to do is just type in 180 minus 105. I just literally Control C, Control V that in, and you can see I got the exact same answer that I got using a calculator. When looking at a side-side-side triangle that is not a right triangle, you're also going to use a law of cosines. Remember, the side-side-side is not talking about congruent or similarity proofs from geometry. It's talking about the given information, and you can see that I'm given three sides. So you immediately, when you see that, you're going to think of the law of sines. Okay, so side, side, side. And it's really important because side, side, side is something that you can easily obtain in the real world. You can easily go out and measure three sides of a triangle. And so you want to make sure that you realize this example is always the law of cosines. But we have a small problem. And the small problem that we have is that the law of sines traditionally is written what you need squared is equal to what you have squared plus the other side you have squared minus twice those two's product and then times cosine, law of cosines, of the angle that corresponds to what you want. Well, here's the problem. I don't have any angles. So in this problem, you're going to have to do the entire problem using the cosine angle formula, right? So the law of cosines for angles is cosine of the angle A. And remember how this works. You just subtract these two on the other side. So that'll give you A squared minus on this side, minus on this side, minus B squared minus C squared. And then if these are gone, you would divide by this coefficient. And so it'd be A squared minus B squared minus C squared, and then divided by the coefficient on the front of this. Then, of course, I reversed it using the commutative property, so it wouldn't be equals that. Now, in other textbooks, you may see this written as B squared plus C squared minus A squared over positive 2BC. When they do that, they factored out this negative. I find that to be actually kind of confusing because it doesn't look like the original problem. So in this one, what we're going to do is we're going to look at this triangle, and we're going to realize that this side across from E is little e, and this side across from D right here, that's little d, or lowercase d. And of course, this one way over here from F, this is lowercase f. And we're going to write these out in terms of F and E and D, not in terms of A, B, and C. So to do that, I went ahead and just kind of pre-did that for you so that you could see it. What I did is I started with D. I just like to start in alphabetical order. That's why I did D. So D would be D squared minus E squared minus F squared, and then divided by negative 2. It's always negative 2 times these two things you're subtracting down here. That's why I like writing it that way, because you kind of keep all the negatives together. It's a really helpful way to do it. And to do this one, the next one I did in order was I did E, right? So I just go in alphabetical order. So cosine of E would be E squared, the side that it has, that matches it, minus the other two divided by twice those products. Remember, all the negatives stay together. So why didn't we do F? Completely unnecessary. You can always use angle sum. If I find two angles, I can find the other angle by simply taking 180 and subtracting these two answers. But before we type this in the calculator, we really have to remember something that's super important, which is I could type this in the calculator, but it's really not a good idea based on, the idea that it's going to, it's not going to be easy to type it. I'm not going to get the answer in one swipe. The highest degree of mistakes is created from how students type this into the calculator, believe it or not. So what I want to do is I want to solve both of these using inverse cosine. So I inverse cosine this, it cancels. Technically, remember, it's the inverse, so it's really just making 1 times d, which becomes d. I mean, that's a lot of information, but just it cancels. Over here, it doesn't. It creates a parentheses of all that. Same thing with this. This will cancel. And then down here, I have the result that I actually want to type in the calculator. And you may be saying, well, why didn't you go and type in all those things? Why did you leave it as D? Why didn't you say it was 5? Why did you say E was 6 and 2 was F? You could, and if you want to do it that way, here's a great place to do it. I want to show you something really neat on the calculator that I think will really open your eyes to how calculators and Desmos can just really make your life easier, especially when you move on past Algebra 2 and you're taking science and there's variables everywhere. So what you're going to see here is what I did was I actually stored. I went back up here and I stored that D is 5, E is 6, and F is 2 by using the store feature, which on the TI is STO, and on a Casio it's a little arrow. It looks just like this. So I did this. I said 5 store D, enter, 6 store E, enter, 2 store F, enter, and then I literally typed it in. Now, sometimes I will do it as separate things. You could have typed it all together, which I'll do in Desmos. You could type inverse cosine and then put this in a parentheses and get the answer. Just make sure your calculator's in degree mode. And you get that the first one that we typed in, which is right here, you can't label it as D. But that's why knowing that this D matches this D, we know that that's angle D. One thing about calculators that's really important is that they can't use lowercase letters. Desmos can, which you'll see. And so when they appear in the calculator, they appear as uppercase, even though we understand that as a human, that means angle, but we're really using it just to save ourselves some time and frustration. So these are actually all lowercase in reality. So it does give you an answer, it gives you a ratio. That's what I want you to see. That's why I did it that way. Remember when we learned about right angles, cosine should be ratios. And so it kind of all just loops back together. If you look at this formula, which starts from this law of cosines, when you get down to the bottom, you're just going back to a normal cosine ratio, and it gives you 51.318 degrees. So then I typed this one in. I didn't need to store these because I already stored them. So I typed that in. It gave me a ratio, and then I inverse cosine. Of course, I could have just done this all in one step, but I didn't want you to lose that ratio. All right, so that's how you would do it on a Casio or a TI. This particularly is a TI, but the Casio looks exactly the same, other than the button for storing is different, and locating the inverse cosine is in a different place. So what do I do on Desmos? Well, on Desmos, I type it in, and I want you to notice something. This is really interesting. Why did I have to type this as uppercase? Because if I type in lowercase e, it gives me a, oh no, I don't know what that is. And if you read it, it says, I have defined e as, E from the previous chapter, 2.718. It's it's Euler's number, or the natural growth constant. So I can't use lowercase e. It's one of the reasons I picked these letters, because I didn't want you to do that and then be like, why is Desmos not working? Desmos has defined E as its definition in the universe. It would kind of be like if I tried to say pi equals 6, right? It would freak out. It would be like, nope, can't do that. Pi doesn't equal 6. Pi equals 3.14. So instead of saying lowercase e for this particular one, we have to do uppercase E. I just wanted to show you that, so I picked those letters. And then I just typed it in. I typed in cosine to the -1, which is under function, right? Make sure it's in degree mode. You could, of course, type arc cosine. I'll show you that works, right? Arc cosine gives me the exact same answer as typing in here inverse cosine. It's the same thing. And then I did the same thing for this one right here. I just typed in inverse cosine of all of that information. It gave me the answer. And then I have the exact same answers you can see here that I have on Desmos. Just make sure everything's in degree mode. That's the number one. The number one thing students do wrong is they make a typo. The number two thing that students do wrong is they do the entire problem in radians and they think they're doing it wrong and they're not. So on Desmos, another thing that students might do wrong is make this capital and put it lowercase here. Just make sure everything matches. That's why I love being able to see it all on one screen. So now our job is going to be to take all this information that we have and organize it. So remember, to organize the information, you're solving the triangle. That's the purpose. Solving means find all angles and sides. So notice that for the sides, I just wrote down what they gave me, right? E is 6, D is 5, F is 2. I just wrote that out over here. You would want to include your unit. So keep in mind that a teacher would look at that and say, oh, -1, -1, -1. You're going to want to make sure you include your units. It becomes more and more important as you enter trigonometry and above. And then this number, remember, I got from right here, right? That number is 51.317. You can always remember what angle you're doing because it's the first thing right here. Remember, that matches. D is angle D and E is angle E. So there are those answers. So how do I get F? Well, I take 180 degrees and I subtract 51.3178. I just literally copied it and put it there. I take 100 and then I subtract 110 and I get that measurement right there. So I can fill that in real nicely and I have the whole thing solved. Remember, this should always add to 180. The sides don't have any of those nice relationships. You can also just obviously do that on a calculator. You could do that on a phone calculator. It just is, you just go to 3 or 4 decimal places. 3 decimal places is important for later AP classes. That's why we're doing it now. I don't want you to do a tenth and then later be told to do with three decimal places. When you take an AP test or an SAT, they're looking for 3 correct decimal places. So that's why I always calculate with maybe 5 or 6 so that my end answer has more than that. So as we go through applications of trigonometry, I'm going to review the ones we've already done and then try to add in a few as we go through the chapter. So we learned in the right angle trig about the angle of elevation, which is the angle something rises from the horizontal. If you need to see a problem like that, please watch the video for right angle trig, but be aware that that could happen in a law of cosines problem. All right. The angle of depression, which is the one that students frequently mislabel, is the angle from the horizontal. Please do not ever put the angle of depression, right? Don't ever write the angle of depression here. This is not where it is. It is here from the horizontal. This right here is called something else, which I'll talk about in the next applications video. So angle of depression goes from the horizontal downward. Angle of elevation goes from the horizontal upward. And now we're going to talk about something called bearings. And bearings are things that you hear sometimes when you maybe hear a pilot talking about going something like north of northwest or south of southwest or southwest. And so bearings are measurements in degrees from a set value on a compass. And so an example of that, you can see my compass that I have here labeled. We of course have north, east, south, west, whatever mnemonic device you use. There are several. In between north and east is northeast. In between east and south is southeast. In between south and southwest, south and west is southwest. In between west and north is northwest. And each of those is 45 degrees because north and east, as you can see, it makes a right triangle. And so each of these are 45 degrees. So if somebody were to say a plane is traveling southeast, well, depending on where your triangle is, you would just write 45 degrees. However, it can come in combination of other things, and you can also have this statement. I want you to listen to this very carefully because it's confusing unless you're taught it, and then once you're taught it, it makes perfect sense. So let's say somebody said, I want you to go 5 degrees south of southeast. Well, what that means is your actual angle is actually here, and this is 5 degrees. So what you would do is you would simply add the 45 you had here, and so when you make your triangle, the total angle would be 50 degrees. And that can happen anywhere around the triangle, anywhere around the compass. Yeah, you could have a problem over here where you're going west of southwest, and you would have to, just add, if I had a triangle that was over here, you would have to add, you could also subtract. Imagine I said something is west of northwest. So let's take a look at that. Let's say I said you had something that was 10 degrees west of northwest. Well, northwest is 45 degrees, right? And if I'm going west of northwest, it could be called south of northwest, just letting you know, because south means down. So west of northwest would be down here, and it's telling me that it's 10 degrees, so I have 10 degrees here. So the actual triangle down here would be 35. So just be aware of how this works. Remember that the compass goes clockwise, which is kind of confusing later in trig, because normal trigonometry goes counterclockwise. But when you talk about compass and bearings, the compass itself goes clockwise. All right, let's take a look at a problem using that. So a plane takes off 15 degrees north of northwest from Miami and travels 600 miles. So let's just start there. What is that talking about? Well, what we're going to do is we're going to draw a compass. Okay, so we draw a compass. And if you need to, you can label it, right? North, east, south, west. And then they're talking about north of northwest. So let's just start with northwest. Northwest is here. And it's north of northwest. So the actual problem, I'll draw it in the same color as the sentence. The actual problem is talking about here, north of northwest. And so it tells me that this right here is 15 degrees. And we know from defining the compass that this part right here is 45 degrees. So we'll have to figure out what we need to do this. But the total idea here is that the whole thing from northwest to north of northwest, 45 plus 15 is, of course, 60 degrees. Now, we may use the 60 degrees, we may not. We may have to use a complement or supplement. Please keep in mind that a supplement is something that adds to 180, and a complement is something that adds to 90. We'll see where the rest of the triangle goes. But for right now, again, and let's go ahead and label this with the actual problem. I'm traveling 15 degrees north of northwest from Miami, so I'll label this M. It travels 600 miles in this direction. So then the next sentence it says, so from this point, this is what the next sentence is going to do. Another plane takes off from the same time due east of Miami. Okay, so this one is actually starting back from Miami. So we're going back to Miami and we're going due east. Well, you can see on the compass that due east is just travel along this line. And it travels along this line for 125 miles. And you can put the units in if you want, but we'll just do it at the end. And so now the question is, well, what's the distance the planes are from each other? So this plane is here at this particular moment in time, and this plane is here at this particular moment in time. And the question is, well, how far apart are they? And as you can see, that is an angle, a side, and an angle in the middle. And even though it gave us this bearing of 60 degrees, we actually need to find, we need to find the angle here, which is from geometry, the supplement. So why don't I just draw you sort of a geometry problem here. We have a 180 degrees, that's what supplement means. And then we have an angle over here. Just drawing that picture with a little less busyness. So we have an angle here that's 60 degrees. And the question is, well, what is this angle? And since this is 180 degrees, this angle in here must be 120 degrees. Right, 60 and 120 makes 180, or you could do 180 minus 60. So now we can come back here and just label this 120 degrees, and now we have a law of cosines problem, right? Because if I look at what I have angle, side, angle. And so the question is, find the distance. So this distance right here is just the straight up law of cosines that we've learned before, a squared, in this case, this side d, would be equal to, and I didn't label these sides, so I'm just going to do the normal law of cosines. So a squared would equal b squared minus c squared minus 2bc, and then cosine of capital A for the angle. And of course, if you want to change this to a d, so it makes more sense to you, that's fine. Just realize I didn't label the other ones, so we can call that distance. Whatever you need to do to see it in your mind, okay? And so what I'm going to do is I'm just going to plug in these numbers I see, right? So the distance is what I'm finding. The angle is 120, so this would be 120. Either one of these sides, it doesn't matter. I did this one first, so we would put 600 here, and we would put 125 there, and then these two would be 600 and 125. So I already did that here, all nice and color-coded. D squared is equal to 600 squared plus 125 squared minus 2, 600 times 125 cosine of 120. And so that distance, remember, if I type that in the calculator, I'm going to get a huge number. So I have to make sure I solve this, right? And I solve this problem by taking the square root of both sides. So what I actually type in the calculator is that the distance is equal to the square root of all of this. Please type it all in at once. Either use a calculator and put it in degree mode, or use Desmos. The thing I like about Desmos is you can actually see the whole thing. Right? The distance is equal to 600 squared plus 120 squared minus 2 times 600 times 125 times cosine of 120. And please make sure it's in degree mode. I mean, look how wacky the answer. Actually, in word problems, it's not always so weird. I mean, if I have it in radio mode and I say it's 503, I would have no idea I had it wrong. And trust me, on an SAT, they're going to put that on there just to, that's the kind of stuff they do on standardized tests. So just make sure you have it in degree mode. And now we can understand that the answer is 671.286. Please use 3 decimal places because that will be how you do things on the SAT and in AP classes. So we're just going to go down here and write the answer. 600, let me get the right color. 671 point, the decimal points matter, 286. And don't forget to label it, and that would be miles. So what's hard about word problems? Learning how to set it up. The actual math that you've already done, it's pretty easy. So really focus on the idea of paying very close attention, color code, Make sure you understand how bearings work in angle of elevation and depression. Draw another picture if you have to try to figure out what's happening. And sometimes you have indirect measurement where, like in this case, they gave you this angle that you found using bearings, but the angle you needed was indirectly found using a supplement meaning 180. This could have also happened with a complement, 90, but typically it's with the supplement because we went dead east. So hopefully that problem makes sense. You might want to rewatch how I did that bearing part, and feel free to just review anything that you might have missed. Again, the other videos from the right angle section are important as well.